Springs. We're in the middle of a windstorm. Let me show you. You can kind of see out there, maybe the wind, or maybe out that way, be even better. Yeah, it's super windy. We came in and it was full-on sandstorm getting into town here. But anyway, uh, let's get going. Chapter 12. How about that? Similarity. Let me share my notes with you, or my. And I think I already gave you this filled out version of this. If not, just find a place to do it on the 12.1 notes. But 12.1 is the idea of similarity, and it talks about what similar figures are. Two components, as in fight on. Two components. Whoa, sorry about that. Two components. One, figures have to be exactly the same shape. But two, they don't necessarily need to be the same size. Okay. In other words, one could be like a scale model for another. Think of two equilateral triangles. One that's like this size, maybe. Okay. And you can think of one that's like this size. That same shape, right? Obviously, all sides are congruent and all the angles are congruent, but not necessarily the same size. Got this cord that's like wrapping around me like a snake. All right. And the symbol for that is kind of the wavy sign. Now, interesting. Think about this as compared to the congruent side, which is the similarity sign with the equals underneath it. Interesting, huh? Interesting. Food for thought. Okay. But we're going to talk about ratio and proportion here. This is used a lot in this section, a lot of ratios and proportions. So remember, a ratio is a quotient of two numbers. And there's lots of different ways to write ratios. One, you could write it as a fraction. The fraction bar, anybody know what that's called, by the way? I don't know if that's come up in this class yet. It's called the vinculum, vinculum. You may have known that. Or you can use the kind of the colon, or 5, 2, 3, and 5 divide. That's a divided by, not a plus sign there, just so you know that. All that is a ratio, okay? And a ratio should always be expressed in lowest terms. And you guys know that. You don't leave a fraction as 2/4 or a ratio as 2/4. You make it 1/2. Okay, so a proportion is an equation that has two ratios set equal to each other. Okay, 1/2 equals 5/10. Each one of those is a ratio, it's a fraction. They're set equal to each other. 3/5 equals x over 20. That is a proportion. Okay, now in a proportion, let's say we had a over b equals c over d. Okay, a, which is in the upper left, is called the first term. You can see b is the second term in the bottom left, c in the upper right is the third term, and d in the bottom right is the fourth term. Okay, now we're going to think of b and c as if they were the means, and a times d as if they were the extremes. Okay, I don't really have a great way of thinking about this, but kind of looks like, I don't know. If you look at them lined up here, A, B, C, D, B and C kind of are the ones that are in the middle, kind of like the mean, I don't know, like close to average or something like that, even though it doesn't necessarily be. But A and D, and those are kind of the ones on the outside. They're getting the extreme temperatures from the elements. I don't know. A, B, C, D, B and C are called the means, A and D are the extremes. I wish I had a better way of kind of helping you to remember that. I think you're just going to have to do it. Okay, but one thing we know is that you've probably learned this at some point, that when you have two fractions set equal to each other, if you have a proportion, you can cross multiply, and the cross products would be equal to each other. And that's what this says here in bold. In a proportion, the product of the means is equal to the product of the extremes. That is, A times D equals B times C. I call that kind of the bow tie method, because see how it kind of makes like a little bow tie there? If you think of it, kind of, I don't know, sort of. Okay, so we know AD is equal to BC. Other properties of proportions are, if AB equals CD, then A over C equals B over D. Okay, and D over B equals C over A. And you can think about how that would work, but does it make sense? Let's see. So let's say we're using this 1 over 2 equals 5 over 10. It's saying, and so A is 1, B is 2, C is 5, D is 10. So then A over C, that would be 1 over 5. Does that equal 2 over 10? Oh yeah, it sure does. What about 10 over 2? Does that equal 5 over 1? Oh yeah, it sure does. And you probably know that from working with fractions. You guys all love fractions so much. I know. Okay, next thing, learning about what's called the geometric mean. Now you've already learned the arithmetic mean, or arithmetic sometimes people mean, and that's the kind of normal mean that you have already learned about probably when you did probability, where you add up all the values, you divide by the number, and that gets you the mean. Well, the geometric mean says that if A, B, and C are positive numbers, and AB equals B over C, okay? So in other words, the denominator of one fraction is equal to the numerator of another, then B is called the geometric mean, okay? And if we cross multiplied, wouldn't we have B squared equals AC? And then if we took the square root of both sides, B would equal the square root of AC. So keep that in mind. So B is equal to the square root of A times C. Okay. So let's go ahead and do these examples. So I want you in this first one, if 3 over x equals 7 over 10, I want you to solve for x, okay? So why don't you go ahead and think about how you would do that? And there's multiple ways. Pause the video and solve it. Okay, I'm back. Now, one way to do this was we could cross multiply, right? You could say, okay, cross products, x times 7 or 7x equals 3 times 14, which is 42. And divide both sides by 7, you get x equals 6. Another way might be to say, wait, 7 over 14, the numerator here is half of the denominator. Well, if these are equal fractions or equal ratios, this numerator is going to have to be half of this denominator. That's another way of figuring out. And there's others too. Okay, let's look at number 2. It says if 3x equals 4y, find the ratio of x to y. Does that say to solve for x? No. Does it say to solve for y? No. It says find the ratio. What's the ratio of x to y? How could you write that? Oh yeah, all these ways up here, including this one. So wouldn't that mean we just want to get one side of this equation to have x over y? Yeah, so how are we going to do that? X is on this side, y is on this side. Well, couldn't I divide both sides by y? What happens on the right side? The y's cancel, right? So I just have a 4, and then I have 3x over y on the left side. Okay, remember what we're trying to get to? X over y, not 3x over y, x over y. So what would we have to do to both sides to get that 3 out of there on the left side? Yeah, multiply by the reciprocal, 1/3, or divide by 3, however you want to think of it. Whatever you do to one side, you do to the other. Those 3's cancel. We get x over y equals 4 over 3. How about that? Okay, nice. All right, number 3. Find the fourth term if the first 3 terms are 2, 3, and 4. Go look up at your notes. Remember what how we would structure those first 3 terms and where the fourth term would be. Okay, did you write a proportion? Did you write that? First term, second term, third term, fourth term? Hope so. And then how would you solve it? Well, I kind of just look at it. If 2 over 3 is going to equal what? 4 over 6. If I've doubled this numerator, don't I have to double this denominator since they're equal fractions? Is another way of thinking of it. Or you could do cross products. Love the bow tie method. X equals 6. Okay, find the geometric mean between 4 and 24. Okay, so you might just remember the formula that B, the geometric mean, is equal to the square root of A times C. Or you might set it up. Remember the geometric mean, B, is going to be the denominator of one fraction and the numerator of the other. So this would be a way of setting up as a proportion. And if you cross multiply, you're going to get what? X squared equals 96, and 96 is the same as 4 times 24. And then we just need to simplify that. And please don't say 2 root 24. Your algebra AB teacher, who I know quite well, would not be happy with that. No, you got to go all the way down. And root 24 is root 4, root 6, right? So we have root 4, root 4, root 6. Root 4 is 2. 2 times 2 is 4, 4 root 6. Okay? All right. And that, my fellow mathletes, is it for 12-1. Hope you enjoyed it, and we'll be back with more.